This video is about aircraft battery load testing. Both high current, that is cold cranking amps, and capacity, which is measured in ampere hours, are important parameters for aircraft. Engine failures usually mean that the aircraft systems depend wholly on the battery power for the duration of the emergency, which could be minutes to an hour or more in many cases. So in those cases, the battery has to provide the power to maintain various aircraft systems, including the avionics, communication, whatever else depends on the battery, may perhaps even heating and cooling systems, whatever. In any case, the load testing using a high current discharge for a few seconds or 15 seconds, which is usually the case that is used for car battery testing, may not give a good idea about the true battery capacity. Also, AC impedance testing, while it's quick and simple, might not be sufficient to give good true confidence in the real world capacity of the battery. So we need to go through a more basic brute force or standard procedure which are specified by manufacturers, which is a complete load test which fully discharges the battery under true loading conditions at the maximum rated current. I usually don't give out disclaimers, but this time I do have to mention these. Please follow the recommended maintenance procedures for your particular make and model number of the battery that you're using and as suggested by the manufacturer. The example numbers, values, and procedures are indicated in this video. Refer to the Concord RG35AXC AGM lead acid chemistry battery. And if you're not comfortable dealing with high currents, you shouldn't attempt this procedure. Everything is for aircraft systems are critical, may involve life and death situations. So please do take the necessary precautions, do your own research for the numbers, procedures, whatever else I mentioned could be outdated, could be wrong, could be misinterpreted. This is a load testing procedure which I'm going to go through. And as those of you who fly aircraft would be highly aware of the importance of the battery. First of all, it's the primary means of starting the plane, and of course you can hand prop it sometimes, but most people don't do that anymore. The second most important use of the battery is to maintain the power for all the avionics, as well as to provide spark in case you have an electronic ignition system. Those of you who don't have an electronic ignition or you use magnetos don't care about the battery once the plane starts, but it's always useful to have the battery as a backup if the engine fails and you need to maintain your power to your avionics. So a lot of reasons why you want to have a good battery which has a decent life and capacity. And there are also rules set by the FAA on what capacity should be there. Anyway, the preparation phase is basically the first thing you do is to check the open circuit voltage of the battery without any load on it. If the VOC or the open circuit voltage is less than 10 volts, you'll have to go through a deep discharge recovery process, which I will go through after this load testing procedure. If that looks okay, and most likely it will be fine if you have been using the aircraft or the aircraft batteries in decent shape, it'll probably be around 11 or 12 volts when when it's been sitting idle for a while. So at around 20 degrees Celsius or 68 Fahrenheit, you apply a constant voltage charge and charge the battery at 14.125 volts plus or minus 0.125 volts using a charging current of at least 0.2 C. C is basically the capacity of the battery in ampere hours. So in case of a 33 ampere hour battery, your charging current should be at least 6.6 amps. You can use a higher current, it will shorten the charging time, but just watch the battery temperature. It's probably not a good idea to charge at extremely high currents. It's just going to heat up the battery as well. So around 0.2 to 0.5 C is probably a good charging current. And then you charge it until the charging current or it becomes in constant voltage mode. it will be less than 0.05 C, or in this case about 1.6 amps, I believe, or roughly that thereabouts, for the 33 ampere battery. Then you charge it for another 4 hours more at the same voltage, and then you can turn off the charger and do the next thing, which is to test the battery. Now, to test the battery, you need to set your a load. You typically need a constant current load of 1 C. That is, in this case, I'll have to discharge this battery at 33 amps. And if you use a resistance to discharge it, you probably won't get a constant current, because as the voltage drops from 12 volts to around 10 volts, your current is going to drop from 33 amps to around 27 amps, which is not a valid test. If you can somehow change the resistance while the test is going on, that's fine, but it's going to be tricky, or it's going to be a time consuming process to do that, or may not be even possible in some cases. So you really need to have a constant current, high power discharge capability, because at 33 amps, 12 volts, you're almost 400 watts of power. So you start the discharge at 1 C, and then start a timer, count up timer, and monitor the voltage every 10 seconds or so. If you can automate that using some kind of test measurement system, that's fine. When the battery reaches 10 volts, you stop the discharge and stop the timer as well, and then you measure the elapsed time in minutes. So the capacity is basically delta T, which is the elapsed time, divided by 60 times 100. If the battery is okay, it will have a capacity greater than 85%. If not, it's going to be less than 85, in which case you've got to recondition the battery and repeat the test. In most cases, in a good battery, which is fairly new and well maintained, it should pass the first time. But an older battery, let's say 5 years old or more, may fail the test. In my case, last year when I tested the battery, I had a capacity of about 84 or 83%. I let it go at that time because I did over discharge it initially at a higher current, so I think it's probably around 85%. So now to condition the battery, you got to do the following steps here. Step 4, you charge the battery at 0.1 C. In this case, at 33 ampere hour battery, the constant current would be at around 3.3 amps. And you have to maintain a constant current, which means you have to set a compliance voltage on your constant current source, and you should set it at something like at least 17 volts. So as the voltage builds up, the source will go into constant voltage mode, most likely when it reaches less than 0.1 C in the current. It's less than 3.3 amps. But you keep charging it for another total of 16 hours. If the battery temperature, that you're going to monitor the battery temperature for this particular test. So if that temperature goes above 55, you stop the test, and you probably may have to just cool the battery and test it again. But if it lasts 16 hours, then cool the battery for about 8 hours to bring it back to ambient temperature. Repeat the test. You can repeat this test twice. That is, you can condition the battery twice and discharge it 3 times as part of the total test. And if it fails the third time, then you basically say the battery is no good. It cannot be recovered anymore. So that's the general procedure. Of course, this takes a while. As you can see, the amount of time involved in doing all these tests, especially the conditioning tests, will take a whole day. This test is just a short 1 hour test, but the pre-charge itself will take also some time, maybe half a day to do this part. So this procedure is a bit time consuming, so you normally can do it during an annual, or if you think the battery is old, but you don't have to probably do it every year for a new battery. But if you have problems starting the plane in cold weather, or you think the capacity is degraded somewhat, you should probably do this test to check the performance or capacity of the battery. The last section I want to cover on this battery testing video is the deep discharge recovery process. How to do that? If your VOC or the battery voltage unloaded at the beginning of the test is less than 10 volts, then you got to do this procedure here. So the first thing you do is set the charger to a constant current mode, and the charging rate is going to be 0.1 C, or in this particular example with a 33 amp hour battery is going to be 3.3 amps, and set the compliance voltage to about 17 volts or so. Then you start the charging. When the battery voltage crosses 15.5 volts, you charge the battery for 4 hours more, and then you can stop the charge. If the battery voltage does not reach 15.5 volts after 24 hours, you terminate the charge, and then you have to basically discard the battery, recycle it, because it's not going to be able to be recovered at that point. It's far too gone to be useful. But there's another situation where if the battery voltage goes past 15.5 volts and at the beginning of the charge, but falls to below 15.5 volts within 2 hours, then you continue charging until it recrosses the 15.5 volt, and then you charge it for another 4 hours after that. So this is a bit of a weird thing, but I'm not sure if this happens, but that's a procedure that was given in my battery manual. And then once all of this charging is done, you can cool the battery for 8 hours and then go back to do the discharge test. So these are the results after the first discharge test. I did a normal charge, and then I discharged it at the rated 1C or C1 rate, 33 amps, and the initial voltage was 13.77 volts, and the battery dropped to 10 volts very quickly, actually after 20 minutes. So the capacity was only 33.3%, which failed gloriously. So definitely requires some more investigation. I'm going to try a reconditioning charge, but I don't expect this battery is going to survive. Anyway, so this is the first discharge charge. I didn't I didn't actually videotape or record this video for this one, but I will show the reconditioning process next, and then go through a second discharge to see how that improved it or not. So this is the battery reconditioning going on right now. It started overnight, last night, with a 3.3 amp reconditioning current, constant current at 17.5 volts. Currently it's dropped to 1.8 amps, and it's been increasing slowly as the battery warms up, and you probably have to go for another 10 hours if possible, as long as the temperature remains below 55 Celsius. This process will continue, and the charge, the constant current, is basically 0.1 C, since this is a 33 ampere hour battery. After this, I will cool the battery for a few hours and then discharge again to see whether I can get the 85% capacity back. So this is the first reconditioning charge. I'm allowed to do 2 before it's discarded. It cannot be reconditioned anymore, or it's beyond repair. So let's see how this battery fares after the first reconditioning charge. The battery temperature at the start of the process was around 15 degrees Celsius. Now it's up to 20 degrees. I'll be keeping an eye on this. Hopefully it will not exceed the maximum temperature, which is 55, at which point I would have to stop the reconditioning process. So it's been about 10 hours right now, and the battery temperature continues to rise. It's around 24 degrees Celsius. The current has increased to 2.3 amps, putting in 40 watts into the battery. It's operating in constant voltage mode charging. Keep doing this for another 6 hours more, and then stop the conditioning process and then retest this battery. It's been around 13 hours now since the reconditioning process was started. The temperature is now up to 34 Celsius, which is 93 Fahrenheit, and we are in constant current mode now, 3.3 amps. I'm going to let it go for a few more hours. I don't think it's going to reach 55, but I'm going to stop it when it's in a couple of hours anyway, so probably get to around 40, I think, which is reasonably safe. And then we do the discharge test again. So here's the setup again under load. I just turned it on, 33 amps into the Acme PS2L 1000 active load. It's drawing 33 amps. I just checked that. As you can see, the current meter on that is reading about 30 something amps, 32 amps. Not that accurate, but it's about a minute and 50 seconds into the measurement. I'll take some readings every 5 minutes on the voltage, and towards the end I will stop it at when it reaches 10 volts. So let's hope it goes longer this time. Okay, this is approaching 15 minutes. Looking a little bit better than last time. As you can see, it's about 11.6 volts and falling at 15-minute mark. Earlier I had about 11.4 volts at the 15-minute mark, so it's a bit better, but I don't think it's going to last the 1 hour for sure. It's probably going to fail within 30 minutes, I feel, but let's see. So the battery lasted for 21 minutes 15 seconds, about a minute 15 longer than the previous first time run. So I don't believe this battery can be saved. Even second attempt at reconditioning shouldn't get me anything more. So the voltage has now recovered to 12.5 after the load has been removed, 12.525, and slowly increasing. But this is not going to be a good battery for an aircraft anymore. So this one is done. Looks like a new battery would be needed. So here's the result of the second discharge test after conditioning the battery. It didn't really improve much. As you saw in the experiment, the voltage dropped to 10 volts fairly quickly again, just about 1.3 minutes longer than the first test. So apparently there is some high resistance inside the battery that is dropping the voltage too quickly, so the capacity is unable to be recovered at this point, looks like. So I'm going to just show another test at 1/5 the charge. Of course, this is not an FAA test. I'm just going to see if I can, what kind of capacity I can do if I do it at a much lower discharge rate. And so that result is next. So this is the third test and final one. I did a normal charge after the last full discharge, and this is not a standard test, of course, for capacity testing, but just wanted to see if this battery could be used for something else. And so I discharged it at 1/5 the normal 1C rating, which is 6.6 amps, and the battery lasted for 124.5 minutes. It should have lasted for 300 minutes at this rate, but at least it does mean that it's got some life in it, and it could be used for something else. And you expect that to happen when you discharge at a lower rate. It's going to have a better capacity. This came out to be 41.5%. So one final test I'd like to try is to use a load tester, one of those high current load testers you can get at typically like Harbor Freight, or one of those portable ones. It doesn't do a long-term test, but basically a short-term high current test for 5 seconds. I'm going to run that and see what that device tells us. Right now the battery is almost fully charged again after being discharged for the last test, which was for the 5-hour test. So let's give this a shot. So right now it's reading around 14 volts on this tester, and I'm going to turn the switch on, discharge it for 5 seconds or so, and you should be watching the deflection to see whether it stays in the green area, and that tells you roughly the cold cranking amps. This battery is not rated for cold crank cranking amps, but amp hour capacity. So there'll be some rough translation to cold cranking amps, and we'll see what we get. So here goes. It's 1, 2, 3, 4, 5. So that gave us about 800 or so cold cranking amps. I probably didn't run this long enough. Perhaps I should run it for 15 seconds, in which case I think this meter would have deflected into the weak section. But in any case, I know that this is not going to give me the right picture anyway. This is a high current test, a cold cranking test versus the capacity test, and capacity test is probably very important as well. So I'm going to give up on this battery anyway, and hope you enjoyed this video, and catch you the next time. I'll probably do a test on a new battery once I get it and see how that compares with these results.